This chapter 4 explains what we mean by a bond's z-spread, how this z-spread relates to but is different from the bond's yield to maturity, and what factors cause the z-spread to differ from the asset swap spread. To understand the concept of the z-spread, return first to our formula for yield to maturity, which will appear below in just a second, and recall that we criticized this formula for its use of one constant discounting rate for all maturities, irrespective of the shape of the yield curve at that moment. The alternative, presumably, is to discount each cash flow over the life of the bond at the zero coupon risk-free rate for that maturity, adjusted upward by some positive credit spread that reflects the particular issuer's financial condition. For the risk-free curve, we could of course use the applicable zero coupon rates of the US government, but convention that has developed is to use instead the zero coupon rate derived from the LIBOR spot and forward curve, which itself of course is often derived from the IRS curve via the bootstrapping technique. If you need to review bootstrapping and the techniques for deriving these various curves from one another, please refer to our module labeled Yield Curve Analysis. There is no definitive reason for using the LIBOR-based zero coupon curve instead of the US government's. This practice has evolved in recognition of the reality that few investors borrow at the US government's curve, or even close to it, while many investors do borrow at LIBOR or close to that. And therefore, using this latter curve will enable us to calculate a credit spread that really does reflect what is, for most investors, the net return from the investment that they can achieve. We can therefore rewrite our earlier equation now to read as follows. Boom. So each cash flow discounted at 1 plus the zero coupon rates, each adjusted upward by S for a credit spread. This leaves us, unfortunately, with a multitude of unknown values for these individual credit spreads, S1, S2, S3, which of course means an infinite number of solutions. The simplest answer to this dilemma is to require each value of Si in this equation, i.e. the S1, S2, S3, etc. values, all to be equal to one another. We therefore rewrite the equation one final time in this manner here, which enables us to solve for this unique value for S, and this value of S is what we call the z-spread. Please be very careful. While we call this a z-spread, it is of course a spread over a zero coupon rate, not a zero coupon rate itself. Some people find this title confusing for this exact reason. Our next step is to illustrate the calculation of the z-spread for our old Alcatel 5-year bond, which we do on a worksheet labeled very creatively z-spread. On this worksheet, column D lists the semi-annually compounded swap rates for all maturities from 6 months out to 5 years. And to keep life simple, We treat all semesters as lasting for exactly half a year, even if the correct convention may be a little different, as it would be under US dollar LIBOR's actual 360 convention, for example. We next derive from the swap rates in column D the zero coupon risk-free curve in this column G. We will not review here the formulas behind these derivations, since they are covered extensively in the yield curve analysis module, but we obviously encourage you to refer to that module if you need a refresher. Armed with these individual zero coupon discounting rates for each maturity, we now add to each of these one single constant credit spread appearing in the cell H21, currently set to be 1%, and proceed to calculate discount factors for each maturity, which we have listed in this column H. We have called these discount factors, as you can see, risky discount factors, to make sure they are distinguished from the risk-free discount factors that you see in this column E. The difference, of course, being that the risky discount factors incorporate the credit spread from this cell H21 we just showed you, while the risk-free discount factors do not. For the Alcatel bond, of course, the whole point of this exercise is to discount its cash flows at these risky discount factors to reflect the specific credit risk, and specifically risk of default, of Alcatel itself. We are almost done. We have listed in this column I the exact cash flows under the Alcatel bond, and then have calculated their PVs in column J, obtained simply by, of course, multiplying the cash flows by the risky discount factors. We sum these PVs from column J at the bottom here in this cell J17 and recognize this amount to be the bond's theoretical price, so 92.55. Therefore, with a z-spread of 1%, the result we are getting, this 92.55 for the Alcatel bond, is a little bit higher than the actual observed price in the market. So we resort to GoalSeek, and of course ask GoalSeek to set this number equal to 92 by presumably increasing a little bit the rate at which the cash flows are being discounted. And here we are with a Z or Z spread of 114 basis points. How does this number compare to the par-par asset swap spread over LIBOR, which we previously calculated to be LIBOR plus 109? We see that it is 5 basis points higher and actually virtually identical in size to what we called previously the theoretical spread. A moment's thought should quickly lead to the realization of what is the reason behind this similarity. The theoretical spread estimated previously of LIBOR plus 115 represented the return from a pure investment, so to speak, in Alcatel, not diluted in any way by a second lower yielding investment. While the LIBOR plus 109 that we obtained via the par-par asset swap was diluted, as we explained in Chapter 3, by the combination of a $92 investment in Alcatel with another $8 investment in AA bank risk, pulling the all-in return down by some 5 basis points in total. The Z-spread, it should be obvious, represents a yield measurement, and more specifically a credit spread measurement, untainted by any such dilution, and so comes out very close indeed to the theoretical spread, and therefore again 6 basis points higher than the par-par asset swap spread. The Z-spread is a more honest measure of the risk of the Alcatel's credit, but again one that is difficult to earn in practice for the reasons extensively discussed. Having taken the trouble to develop this nice worksheet, Z-spread, with the individual risk-free discount factors as well as the risky Alcatel discount factors, we will proceed now to use it to price very rigorously the par-par asset swap package for Alcatel. The key difference this time is that we convert the $8 of upfront unused cash into a semi-annual annuity by using the individual risk-free discount factors for each separate maturity, rather than our earlier, less sophisticated technique that simply relied on one single 5-year semi-annual IRS rate to convert the upfront $8 into 10 equal semi-annual installments, irrespective of when these payments actually fell in the future. So now, in this cell K6, we proceed to estimate the size in US dollars of the first payment under the desired annuity, which, as you can see, we have set to exactly $1 for now. And then we have made all the remaining cash flows in the annuity obviously equal to one another. And then in column L, we have PV'd these cash flows simply by multiplying each one by, careful now, the risk-free discount factor appearing in column E. Hence, in the formula here, you see a reference to K6 times E6. And lastly, we sum all these PVs down in the cell L16, and observe already that we are very close to $8, but not exactly there. Now, goal-seek, setting this amount equal to exactly $8 by changing that first cell here, reveals for the semi-annual cash flow an answer of 0.9381. Therefore, these two semi-annual cash flows together, as you can see right at the bottom of the slide and of the Excel spreadsheet, sum to 1.876. Let's call that 187.6 basis points. Remember, we were at LIBOR minus 80, and when we add this amount to the LIBOR minus 80, it gets us up to LIBOR plus 107.6. LIBOR plus 107.6, which is very close to, but not exactly matching, the previous result of LIBOR plus 109, derived under the cruder approach. Presumably, we should expect this gap between the asset swap spread and the Z-spread to increase the deeper the discount from par at which the bond trades, since the dilution under the asset swap structure would increase further then. If our Alcatel bond were trading at 80 instead of 92, for example, the par-par asset swap package would now represent as much as $20 per 100 the credit risk of the AA bank, and only $80 per 100 the pure Alcatel risk. So it would be far more diluted Alcatel exposure than it was before. Both measures will of course turn out higher than when Alcatel traded at 92, but the Z-spread should rise substantially more. Starting with the Z-spread, we simply goal-seek our way to a price of 80 instead of this 92 from the previous trial by allowing the Z-spread to change as well. So Tools, goal-seek, set this cell J17 to value 80 by changing the Z-spread, hit OK, revealing a Z-spread of 448 basis points in cell H21 right here. We now turn our attention to column L for purposes of calculating the asset swap, and we see that the annuitization of the upfront unused amount of $20 instead of $8 here will be obtained by allowing this cash flow, if you recall, to change presumably upward by about 2.5 times, bringing the PVs here up by 2.5 times as much, hence to the targeted 20. So we proceed once again. Tools, goal-seek, set this number here equal to 20 by changing the individual cash flows, hit OK, and remember we really need to add together two cash flows here and realize that together they represent, as you can see at the bottom of the slide, 469 basis points. So the $20 shortfall can be converted into an additional 469 basis points, and if you just go a little further down in the spreadsheet, you will see our previous LIBOR minus 80 is now supplemented by 469 and brings the asset swap up to LIBOR plus 389 basis points, demonstrably lower and by several dozens of basis points from the Z spread, which was 448 if you recall. In an upcoming module on the cash CDS basis, which will examine the factors behind observed differences in an issuer's credit spread in the bond versus the CDS market, you will have to think hard about which of our three measures, namely the theoretical spread, the asset swap spread, and the Z spread, is more appropriate as a gauge of the pure credit risk of an entity, especially for purposes of comparing it to the CDS spread.